Assalamualaikum and hi. My name is Muhammad Anwar bin Abu Haiyan. Welcome to BMFR 3223 CAD stroke CAM stroke CAE subject. Today we're gonna discuss about our project report, which is our title, which is Sprocket Hub. For introduction, CATIA is a multi-platform solution for computer-aided design, manufacturing engineering, 3D and product lifecycle management, solid surface assembly, drawing, production, and analysis are all possible with CATIA software. And it also used to assist with engineering and design for a variety of projects in a variety of industries. For a decade, it has been significant in applied computer science and also a manufacturing technology that employ computer software and automate machinery to produce a high precision goods. And for selected design, the product is chosen is a Sprocket Hub. Sprocket Hub are used to convey rotary motion between two shafts in a bicycle, motorbike, track, vehicle, and other machine. It is required to design the Sprocket Hub 3D model using CATIA part design module, generating a detailed drafting for a mechanical part and also applying a principle of CAD CAD in a creating 2D sketch and 3D model.
Good evening, my name is Sivanesan and I'll be explaining about the part design. As from the explanation of the introduction from my friend, we'll be designing a Sprocket Hub. Although the design of the Sprocket Hub looks very complicated, it is actually very easy to design. So we have total of 6 features used in the design of the Sprocket Hub. So let me run through the entire process of designing a Sprocket Hub. So first of all, what we do is we draw a circle and we pad it so that it becomes this cylinder. Once that's done, what we do is we draw an inner circle and we pad it so that we'll get this design, which is the nose of the sprocket hub. Once that's done, what we do is we draw this shape where the shaft and also the key sits. So once that's drawn, what we do is we use the pocket feature so that we can cut and we'll get this hollow shape. So once that done, what we do is we draw these two designs. These two designs is very different from each other. So what we do is we draw both of the design and we use the pattern feature so we get 3 of each of the designs. So once we get all the designs, what we do is we use the pocket feature and we cut it. So we have all this completed. Then once that's done, what we do is we draw this circle. You can draw wherever you want on this cylinder. So we draw one, and what we do is we use the pattern feature and we pattern so that we get 6 circles. Once that done, we use a hole feature so that we can get this hollow hole on the cylinder. Then once that done, what we do is we draw one of the shapes, and what we do is again we use the pattern feature so that we can get this all the shapes similar. And once that done, we use the slot feature and we cut it so that we can get this hollow depth cut. And once that completed, what we do is we use the chamfer feature so that we get a chamfer here, and also outer of this cylinder. And once that all completed, what we do is to give it a proper finishing, we use the fillet feature and we fillet it here, and the whole design is complete. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Hasanain bin Hayatul Kamil. I will continue this presentation with an explanation of this drawing. This drawing shows the three-dimensional of the Sprocket Hub with the scale of 1 to 2. It shows the asymmetric view, the colored one, the front view with their dimension, the top view with their dimension, and the side view with their dimensions. Next, this drawing shows two sectional views of the Sprocket Hub, section view A to A and section view B to B. This drawing also shows three 2D details view, details C, details D, and details E of the Sprocket Hub.
Greetings, I'm Enoch Liansim. I'm going to explain the simulation on how the Sprocket Hub machining process. Firstly, we're going to start with facing machining for upper surface of the stock. Then, using a pocketing machining for the rounded trapezoid hole shaft and the rounded triangle hole shaft. After that, for making the circle hole, we use a drilling machining in order to drill 5 of the circle hole. Again, using the facing machining to remove excess material or stock on the top surface of the Sprocket Hub. Then, cutting the stock on around the side of the Sprocket Hub using profile contouring machining. After that, creating a slot, fillet and chamfer by using an isoparametric machining process. Finally, drilling the middle hole using a drilling machining for the last process of the Sprocket Hub.
I am the last presenter and my name is Amirah Binti Adani. To summarize, CATIA is a great tool for organizations to come up with new product design, to conduct thorough analysis, and to create new items, all of which can aid with product development. OEM and manufacturer in a variety of industries can benefit from CATIA since it allows them to speed up the analysis, design, and manufacturing of new products. CATIA is useful for system architects, engineers, and in product developments, because it unifies multiple techniques in product design and development, allowing various disciplines to use the present tools in different stages of product development. Nevertheless, the Sprocket Hub was successfully sketched and simulated using CATIA without any difficulties. In the Sprocket Hub drawing, all of the features were effectively integrated. Pocket, hole, slot, pad, and chamfer were among the features used in the drawing. The Sprocket Hub was also effectively simulated, resulting in a successful design project. With the end of the sentence, we conclude our presentation. Thank you.